Okay, so you are starting calculus-based physics course. What do you need to know before getting into the class? What is the instructor going to expect that you would know? And it depends, of course, on what class you're in, but I'm talking about my class. I'm teaching, this is for, it's called Physics 221. What do I expect that you know? Let's just go through some things. Number one, algebra. So what about algebra do you need to know? You need to know how to solve a quadratic equation. So you need to know something like ax squared plus bx plus c equals 0. What's the value for x? That comes up. I mean, not a ton, but you do need to understand that. You need to do two equations to a known, so something like this. Trying to think of a good example. Here's just an actual example. How about that? X equals x0 plus v0t plus 1/2 a t squared. That's one of the kinematic equations. And then let's say v equals v0 plus a t. Can you rearrange these two equations so there's no t? Right? Get rid of the t. So solve this for t and plug it in there. And that's not too hard. But simple, basic algebraic operations like that are really important. We use those a lot. We do a lot of algebra. We do a lot of symbolic math. So that's one thing that we do in algebra. The other thing that comes up, and I think it's important, and it's sort of, I hate to say it, slope. If I have a graph of position versus time, and say the function looks like this, how would I find the slope right there at that point? Well, there's actually two ways you can do that. You can do this. I can take a small segment right there. I can say this is x1, x2, and then follow this over here, t1. That's t1. T1, T2, and that's x1, x2, and then I can say V average, which would be the slope, would be delta x over delta t, which is x2 minus x1 over t2 minus t1. So that kind of stuff. What is the slope? If you say things like the slope is x over t, it's totally not. X over t gives you that, assuming that's x equals 0, t equals 0, it would be the slope of this line, which, well, actually is pretty close. When you want the slope of this, which is a little bit different. If you put it right here, then that's x over t, and the slope is actually negative. So you want to be careful. What is the slope? How do you make graphs? How do you read graphs? That one is super important. The next big thing, and these are just the basics, right? If you know these things, you're good. If you don't, you need to figure them out, and that's fine. And I'll help you, but you do need to know them. The next thing that comes up a lot is trig. We use trig a lot. Trigonometry. I don't want to spell it out because I'll make a mistake. So the most fundamental thing to know about trig is that it's about right triangles. So if I have a right triangle, so this is an angle, right angle. Then we could call this A, B, and C. So number one, the Pythagorean theorem is part of trig, really. And it says that A squared plus b squared equals c squared. Okay, so that's just a relationship between length of those sides. If this is the angle theta, and it doesn't matter how big my triangle is, if I know that's my angle theta and I know that's my right triangle, then all these triangles with the same angle theta and a right angle there have to be similar. And that means that the ratios of sides have to be the same. And that's what trig is. So if I take the cosine of that angle, then it tells me the ratio of the adjacent to the hypotenuse. So this is going to be A over C. Since this is a ratio of lengths of sides, it doesn't actually have to be length. It can be velocities, it can be force, it can be whatever you want. Then this has no units. Cosine theta has no units. Cosine theta cannot be greater than 1. Cosine theta can be less than -1. Okay, it can be negative, right? Because if I move this over here, if I have it doesn't look like a triangle, but if I have it like this, and here's my angle theta, then this is my x component, and it's in the negative direction, so that is possible. So, but this has to be between -1 and 1, and it has no units. And then if I want to go backwards, if I say I know the ratio, what's the angle, then I could say I want to say theta is going to be equal to the inverse cosine of A over C. That's the arc cosine. Let's go ahead and say it. Units matter. There are two types of units for angles. We have radians or we have degrees. Radians is a better unit. People think in degrees. If you use a calculator, make sure you know which one you're using. Make sure you know how to convert between radians and degrees. It is important. The other two trig functions that we use are sine. Sine of theta is an opposite over hypotenuse. It's B over C. And then tangent of theta is going to be opposite over adjacent. So it's B over A. The other secant, cosecant, all that other stuff we don't really use. There's a lot of other formulas like double angle formula and things like that. I don't expect you to memorize those. You do need to know sine, cosine, tangent. You need to know those. We use them a lot. We use them a lot for vectors. Vectors is our big deal. Okay, so let's talk about vectors. I'm not going to go over vectors. I'm just going to tell you what they are. Vectors is a way of representing a variable. Let's call it a velocity v, with more than one piece of information. So it could have a component in the x, y, and z direction. So that's three components. So it's three pieces of information in that one thing. If you've never seen vectors before, I'm okay with that. That's a thumbs up. Okay, it's fine to not know about vectors. I'm going to teach you stuff about vectors. But in order to really understand vectors, you need to understand trig. So that's why it's important. And I'll go ahead and tell you, for the second semester of physics, it focuses on electric and magnetic fields. There are a bunch of vectors, a whole bunch of vectors. Okay, now let's talk about the calc-based. So we have two things. We have this velocity x is dx dt. It's a derivative. I wrote that poorly. If you're in calculus right at the beginning, you may not have. We changed our course. Originally, you had to have Calc 1 before taking this course. Now you can take them at the same time, and I think it's okay. We do use derivatives, but I think you'll learn a lot about derivatives in this course. Okay, in calculus, you'll say Vx is the limit as delta t goes to 0 of x of t minus x of 0 over delta t. Okay, and that turns into a derivative. So, and then from once you get into derivatives, if you haven't done that, that's fine. Let's say derivatives. You need to know the power rule. I mean, we don't use this a ton. Trig functions, chain rule, product rule. If you can do all those things, I think you should be fine in Physics 221, and hopefully you'll learn a lot about derivatives by using this in concrete examples. What about integrals? So an integral would be something like delta x is the integral from t1 to t2 of v dt. Yeah. And I think the number one thing for integrals, again, we're going to learn about integrals. Again, power rule, you need to know that. Trig integrals. And, the fundamental theorem of calculus is that an integral is the opposite of a derivative, which is really kind of weird. The other thing, what is a derivative? It's the rate of change of a function. What is an integral? It's a sum of areas under a curve. And it turns out that it is the opposite of a derivative, which is actually kind of weird. I'm not going to do, I don't think I'll do like integration by parts or any complicated integrals. I want you to understand what an integral is. We'll use this when we talk about work and energy. I don't really want to challenge you on the most complicated integrals. You should do those. You should do those in your calculus class. But I really want to use integrals. So if you use an integral table, I'm totally cool with that. There's one other thing that I do, and I don't want you to freak out, okay? And I'm going to show you how to do it. Python. So Python is a I think a fairly easy to use programming language, and that allows us to do calculations that couldn't otherwise be done, and calculations that could be done, but it just makes it a little bit easier. So I'm going to show you how to use Python in what we call numerical calculations. I'm going to show you everything. So if you've never programmed before, that is totally fine. Calculations. And the basic idea is, let me draw a graph. Let's suppose we want to integrate. I want to integrate this curve. In Python, with the numerical calculation, what I could do is, in calculus, you would have, f as a function of x that you would integrate. But if you don't know f as a function of x, that's fine. What we're going to do is actually break this into a finite number of pieces and make some approximations, and then just find the area of this, area of this, area of this, and add them all up. So you take a complicated problem and break it into a bunch of smaller, easier problems, and that's why we use Python. Because if I break this into 100 pieces, you don't want to do 100 calculations. Although you could, and it has been done before. And so that's how I'm going to show you how to do it with Python. So there's nothing special about Python other than it's easy to use and it's easy to pick up. You could do this in other programming languages. You could do this in on paper. You could do this in a spreadsheet, which is what I used to do, but I don't like that anymore. But I'm going to show you how to do this. It's going to be exciting. It's fun. Hopefully you'll learn something about that. But other than that, that's what I expect you to know coming into the course. Other than that, how to read the book and how to take notes. The book is really good. Most of those books are pretty good. So I would encourage you to read ahead. You don't have to understand what's going on before you get to the class, but take a look at it, and I think that should help. Okay. I'm ready to get started.